Welcome to our first lesson this week on linear relationships. Before we begin, I'd like you to either copy this on your home printer or just take notes for the four markers we're going to talk about for linear relationships. I also want to let you know that usually our first lesson tends to be a little bit longer than the rest of the week's lessons because we're trying to front load all of the information. So let's get started. A relation in math is a relationship between a set of values, and relationship means a connection of some kind. For this unit, we will discuss the relationship between the set of x values and y values of an ordered pair. So this relationship is how our x values and y values connect in some way. A linear relationship is a special kind of relationship that can be represented in several ways. The first way is a graph. A linear relationship in a graph will form a straight line. Hopefully, you might have noticed when we're talking about the word linear that actually the word line is in linear. So linear relationships, and there's two kinds, proportional and non-proportional, always form a line on a graph. Next, tables. A linear relationship in a table and ordered pairs are what is formed in a table. X and Y column make X and Y ordered pairs. So a linear relationship in a table and ordered pairs will demonstrate a blank of change. And it is a constant rate of change. At any time, you may pause this video in order to take notes. The third way that linear relationships are represented are in equations. Typical linear equations contain the variables blank and blank. So that would be our x and our y. However, as mentioned up above, it says typically we use these. X and y could also be, for instance, if we were talking about the relationship between gallons of gas and the cost, we might use instead G for gallons and C for cost. So we don't always use X and Y, but those are kind of the standard variables that we use. The next important point, particularly for a linear relationship, is these variables are not raised to a power, meaning I will not see x squared and I will not see y squared. So I will not see x squared in my equation and I will not see y squared in my equation. So let's look at what these equations might typically look like. First of all, we have y equals 3x. You're going to notice that both of these equations, or this equation has a y value and an x value. And it happens to have a number that we call a coefficient of x. The next equation, y equals 5x minus 1, we also have a y and an x. This one has a coefficient, meaning a number in front of x, and it also has a number right there without a variable that we refer to as a constant. It looks very similar if we didn't have this minus 1. And then the last equation, if we look at this, 4x plus 2y equals 10. Once again, I want you to notice that we see an x and we see a y. And in this case, the constant is on the other side. So we're going to discuss the various forms or types later on in our conversation. Finally, the fourth type or way that we might see a linear relationship represented would either be in a diagram or in an illustration or more than likely a verbal description. So a linear relationship in a diagram or illustration will also demonstrate a constant rate of change. Once again, when we work with linear relationships, there's going to be a connection or a relationship between two different quantities, say for instance, gallons of gas and the cost. So now let's go to the next video, and in that video we're going to create a reference sheet which shows these 4 different representations of linear relationships. However, there are 2 different types of linear relationships, and that's what we're going to work on next.